going to note that one of our engineers, Winston Cheng, who's the maintainer of the plot, did some tests on alternate ways you could implement reference classes, more or less the same semantics, with much, much better performance. It turns out that a lot of the slowness comes from being based on S4. Okay. And if you do reference classes based on just simple lists and closures, then you get 50 times faster performance, just in terms of the function overhead. Okay. Obviously, it's not going to make it RStudio magically. So
it's kind of a cryptic link there. How would I go about finding it with some keywords, RPups, reference class?
Maybe. Yeah. He only sent this internally to the company, but yeah, maybe if you find me afterwards, I'll send you a link.
All right. Thanks.
Okay. So so let's talk about Shiny. What is Shiny? Has anyone here tried Shiny before? Oh, okay. You guys can tune out for the next 10 minutes, and then it'll get interesting for you again. So Shiny is interactive web applications and reports around your R analysis. It is not it's not designed to be a general purpose web framework. It is not a replacement for Ruby on Rails or for Python Django or the PHP language. Shiny is specifically designed for R users who are doing data analysis to then be able to create applications that display that analysis in an interactive way. It doesn't require any HTML, CSS, or JavaScript knowledge. We understand that's a huge barrier for many, many R users. But many other R users do know HTML, CSS, and JavaScript, and Shiny doesn't hold you back from using all of that knowledge. So you can customize your applications very easily using HTML, CSS, and JavaScript if you are familiar with those technologies. It's useful for a lot of things. We've really been surprised by all the things that people have used Shiny for. It's useful for interactively exploring your data, obviously for reporting. A lot of people have told us that they'd much rather, instead of just telling someone their conclusion, give them an application to let them play with the data, the assumptions themselves, and come to the same conclusion. For dashboards and for collaborating, especially between people who know R and people who don't know R, but maybe know how to interpret the results more than the R users. So Shiny applications are designed to be deployed to either the cloud or to your own servers, or you can just use them locally in your own R session without deploying them anywhere. But if you do deploy them to the cloud or to your own servers, then users who want to use your applications, they just need a web browser. They don't need to have R installed. They don't need any packages. We have a vibrant and active community. Our mailing list is up to about 2,000 users, and there's 15 posts a day. Lots of companies are using this, and there are a lot of packages being developed that extend Shiny and give you new widgets and new ways to work with Shiny. Okay. Any questions so far? All right, so let's just jump into demos. That's all I know how to present is just by doing demos. That's what the rest of our time is going to be. So the first application here is one called K-Means. This is running on our cloud service. So this is a very simple application. This is kind of what I consider the hello world of Shiny. So here on the left, we've got X variable selector and Y variable selector. And these are just the columns of the famous iris data set that comes with R. And so you're choosing which of these columns map to the X and Y variables on this plot here. And then we perform K-means clustering on it, and you can choose how many clusters it should try to create. So if I change these, X and Y values, you can see that the plot changes, and as I change the number of clusters, you can see it automatically updates. So like most modern web applications, you don't have to hit a submit button and wait for the spinner and have it reload. Everything kind of works interactively. And let's take a look at the code for this particular application. So almost all Shiny applications are composed of two files, server.r file and a ui.r file. And the ui.r file is what specifies how the application should look, the basic user interface. And can you guys read that okay? Is that a little small? Okay. In this particular case, we're using a template called page with sidebar. And a page with sidebar has a title. It has a sidebar here. I don't know if you can see, but there's a gray background here. And then it has a main area. And you can see here in the code that's reflected pretty much one for one. Here is inside of this page with sidebar, we have a header panel. We've got a sidebar panel that contains a few controls. And then it has a main panel. So it has a very direct mapping between the code you write and the UI that's generated. Now, these particular inputs, the first two are select inputs. That's what we call these drop-down boxes. The first variable, the first argument here is essentially the identifier for that particular input that I'm creating. So this is xcall. That means I'm going to use the string xcall to refer to this value later on when I want to actually do something with the value that the user selected. The same thing with ycall here. This next argument is the label that's shown on the actual user interface. And then these are the choices that are presented to the user inside the dropdown. So in this case, just the names of the iris data set. Numeric input is similar. The most important thing here to note, again, is that this is the ID. So we'll be referring to clusters when we're looking for that input value later. And then finally, we have output works the same way. So I've got a plot here that's going to represent some output, and I'm calling it plot1. That's how I'll refer to it later. And in this particular case, I'm setting the height to 600, but you can set it to anything. Okay, so does that all make sense so far? So this here looks like a kind of maybe like a widget toolkit or something like that. But in actuality, this is all just HTML. So you could grab any one of those lines of code and just execute it at an R console, and what you'd see at the R console is HTML code coming out. And that means that you can also extend your user interfaces arbitrarily with HTML. So if you're familiar with HTML, then you can just directly put in divs, h1s, tables, whatever it is that you want, form controls. And if you aren't our user who's very familiar with HTML, then you can take those HTML generating functions that you create and bundle those as an R package, and now you can let other people who don't know HTML take advantage of these creations that you've made in HTML.
So just for understanding, so I can mix up R code with HTML code in the server.R file?
That's right, in UI.R. So let me actually show you how that works. Sure, yeah. It took a little longer than I thought it would. Okay, so here's that same application running locally on my machine now. So I can write it here, say between this select input and the next select input, if I want to put a horizontal rule here. So we basically take HTML and transliterate it to R, or the other way around. So I can say HR. And then now when I reload it, there's an HR. It's very faint, but you can see there's an HR there. And if I forget exactly.
But it needs to be in R functions. It can't be plain HTML code. And
right, so you can't do this, for example, that won't compile. But what you can do is you can say include HTML and give it foo.html, and then on disk you have
HTML. Use
HTML.
the HTML function.
Oh, right, you can also do this.
Okay.
There are many ways, many ways to get into it. But we find that writing these R functions that actually generate HTML end up being a really nice way to do it, because you get all the advantages of working with R. You can make functions that generate HTML. Okay, so okay, so let's flip over to the server.R side. And here, the main thing to notice here is the actual code that performs the analysis is pretty much what you would write in R anyway. So let's take a look. So what do we need to do? We need to subset the iris data so that it only includes the two variables that the user selected. We want to then perform k-means clustering on it, and then do a plot that includes both the original points and the cluster centers while coloring according to the clusters. So here's that subsetting operation. So we do iris, and then we're just grabbing the x col and the y col as the columns. Then we're doing k-means clustering based on this selected data. And the number of k-means clusters that we're creating is based on what the user told us they wanted. And then here is just regular plotting code. We're setting the margins. We're plotting according to the colors represented by the clusters. And then we're adding some points to represent the cluster centers. So everything about this should look pretty familiar, except for these particular keywords here: reactive, and remember plot. And also the fact that selected data is this subset of data, and yet when we use it, we don't just refer to it as a variable, we actually use it as a function. So this is the reactive programming framework that Shiny includes that makes it much more concise and more robust to write these applications than traditional programs. And I won't go too far into it today, but what this reactive keyword means is I'm going to perform some computation here, and you, Shiny, make sure that it's always up to date. Okay? In this particular case, it means when input x col and input y col change, then selected data now needs to re-execute and come up with a new set of selected data. And clusters, relies on selected data. So when selected data changes, because clusters is also reactive, it'll say, oh, I myself now also need to change. And similarly, render plot uses selected data and clusters, so when those change, then it itself needs to change. So let me just give you a quick demo of how that works. So when I change this, you can see that all three of these pieces of code highlight. That means that they're executing in response to me making this selection. Now, that makes sense because when I'm choosing a different set of data, we have to recluster it and we have to replot it. But what about if we just change the number of clusters? Well, this time, only those bottom two chunks of code have to change because we're not changing anything about what data is selected. And then finally, if I change the size, that will force the plot to redraw, but nothing else. We don't need to recluster, we don't need to reselect the data. Okay? So that's what reactive programming does for you. You can express your computations more or less the same way you would have done in a straight line piece of R code, except that you add these couple of reactive keywords at the right places. In return, the system knows the minimal amount of code that needs to execute to keep everything up to date. Okay, so that's a pretty simple example. Let's jump to a rather more sophisticated example. The other thing that's really exciting about Shiny to us is that it lets us bridge the worlds between JavaScript and all the really interesting things that are being done with interactive visualization in JavaScript and the R world where such interesting things are possible using computation. This particular example, sorry, it's a little bit US-centric, but it is it's based on a study that was published in a Washington Post earlier this year about this idea of super zip codes. So zip codes are our postal codes, and there was a particular researcher who ranked all of the zip codes in the United States by how affluent they were and how well educated they were. And the zip codes that ranked in the top 5%, he called them super zips. So on this map, there are many red dots. The size reflects the population of that particular zip code. And then there's just a very few blue dots, and those blue ones are the super zips. So if you click on it, so Redmond, Washington, that's Microsoft country. 96 out of 100, right? If you go to, let's say, long view, 37. Okay, so you can see that there are these great big disparities between different zip codes. We can use this, this interactive map is based on a JavaScript component called Leaflet, and it's basically like a clone of Google Maps. And it lets us, zoom in at all different levels. And as we do so, the map will respond. So the other thing to note here is I've got these couple of graphs here that are generated by R. And what this is showing us are a histogram of the superzip score just of what's within our visible bounds of our window right now. So this is showing the San Francisco Bay Area, and you can see that there are some really, really high-end zip codes here, and several really low ones as well. And this scatter plot is showing education along the bottom and income along the top. And these axes are fixed across the United States. So you can see that, if you're up here, this is really the top income in the entire country, and then this is the top college, top educated across the country. If we move to somewhere that's maybe has a different demographic, let's say, sorry, Nevada. Yeah, you're in a very different, you can see like these values all cluster around in a corner here. So this application, sorry, there's one more thing to show here. We have this, if you want to see the same data in sort of tabular view, we're using an interactive table library called data tables, and I can search based on Washington State. Let's say Washington and Oregon, and show me the top superzip scores, between those two states. And then you can search on cities that happen to be within Washington and Oregon. Okay. So pretty much this entire application was written in, I think it was 250 or 300 lines of R code. And really it was almost completely composed of R. Or at least the parts that are specific to superzips were in R. And if we take a look at what the code looks like, this is the server side of it. Most of this is just doing the kinds of things you always do in R. You're subsetting, you're making histograms, you're looping over variables. There's very little here that is related to the web, that's related to user interface programming. It's all very straightforward analysis. And that's our goal with Shiny is to put this kind of power in your hands without having to go and learn a lot about JavaScript or web programming. So, okay. I've got 6 minutes to describe to you 2 man-years of work.
There's a reason you're coming next. How was the demo?
So this, I'm afraid that the technology is cooler than the demo I have for it, just so far, because it's very, very new technology. So we are really excited about this. Shiny up until now has been useful for creating web applications like the one that you just saw. And I think earlier when someone asked whether any of you have used Knitr or SWeave, many of you raised your hands. And ever since the beginning of Shiny, people have asked, well, how can I combine the interactivity of Shiny with the expressiveness of Knitr and on Markdown documents? And we didn't really have a good answer until now. Some users have tried to figure it out, but we've really put a lot of work into trying to combine these two things over the last few months. And interestingly, what we found is that when you use Shiny in this way to create interactive R Markdown documents using Knitr, the result is even simpler than using Shiny on its own. But it's actually an easier way to use Shiny than if you were just use Shiny. So let's take a look at what that looks like. so I'm going to start with some regular autocode. Is that still legible for you guys? Can you do that? Back there? Okay. Okay. RStudio, the company, we operate one of the more popular CRAN mirrors, and we publish the download logs on a public website. So anybody can take a look at, sorry, I'm not in a good state. Anyone can look at the relative popularity of okay. So you can see here we've got, I didn't know. We've got date in one column, we've got the name of the package, and then how many downloads for that package on that date. And we've got 2.27 million rows in this data frame. So let's say we want to compare the 3 different packages that interact, that serve as a bridge between R and bugs, I think for some kind of Bayesian thing. I'm not a stats person. And I want to use the relative number of downloads as sort of a proxy for which one is most popular and most likely to be supported. So I'm going to go ahead and only look at rows that are from 2014 onward. If you haven't seen this weird operator in the middle, this is the plier, and it's quite exciting. You can see here now that my date has now shifted. It begins with, I'm not sure why there's something on New Year's, but okay. And I'm going to filter it to just include those 3 packages. And sure enough, I'm left with just those 3 packages. Okay, so now let's plot it using ggplot. Okay, well that's quite noisy. There's a lot of weekends in here. Those are those huge drops, and it's kind of hard to see any trends because of all the noise. So let's apply some smoothing. Okay, that might be a little too smooth. There's not very much happening anywhere. So I just arbitrarily changed this span variable to 0.4, and now it looks, okay, I'll stop there. You know, but I chose that span variable, and now that's kind of encoded into my analysis. So let's really quickly change that to emitter document. And we've got the same code. We're just doing it in an emitter document instead, in an R Markdown document. Okay, great. So we have the same outcome here. So now let's take a look at what we can do if we combine Shiny with this particular application. So in this case, I don't have a great imagination, but I thought it'd be great to filter based on user-selected dates rather than just arbitrarily choosing the date range that I, as the author, care about. Certainly, these are not the only 3 interesting packages that a user might want to look at. And then this smoothing variable, this span variable, it kind of bothers me that I just arbitrarily chose one, and I'd love for the user to be able to play with that. So I've got this separate file, cranlogs2, that's the same thing, and a couple differences to note here. You add this line runtime : shiny to the top, and that is telling, this is R Markdown 2, the library that's driving all of this, and that's telling the system, by the way, this document may contain some shiny elements, so you need to treat them accordingly, and a lot of magic kind of comes into play there. And also, this knit HTML button in the RStudio interface becomes run document. So let me go ahead and run it first. We'll see what it looks like. Okay. So now we've got an interactive date range selector here. Change it to March. I have a filter box here that'll let me type in any package, so I can do knitter, ggplot2. And then I can change the smoothness to whatever makes sense. Okay. And if you look at the code here, it's really quite simple. So we had that date range selector, That is a date range input function, exactly the same one that you would use if you were writing a Shiny app in your UI.R. You give it, again, this is the ID, date range, and then this is what the user is going to see, period. And then you have a set of start and end dates and min and max dates. And again, we use a reactive expression to say, this is the data that is filtered according to the date range. And again, we see input date range. We've got the same select input that we had before. And again, another reactive expression that filters by what packages were selected. And then a slider input for the smoothness. And then we do the same ggplot expression that we did before, except now we again wrap it in a render plot function. So this is the basic style that you would use for any interactive Shiny document. You would add a set of inputs. Your calculated values you would wrap in these reactive calls. And then any outputs, we could do tables, we could do plots, we can do text, need to be wrapped in a render plot, render text, a render table call. And once you've done that, you just hit run document, and you've got an application that looks a lot like a knitter document, but it behaves a lot like a Shiny document. So this is all brand new stuff. If you want to try this out, you have to download the newest version of RStudio, and then you can go to new R Markdown, and Shiny is one of the options. There's a link here that will tell you much more about how you go about creating these things. It'll walk you step by step, do some examples. This is all very new. The specific talk about the interactive reporting stuff is very new. We would love your feedback on this. We're counting on a couple rounds of making improvements based on user feedback before we go onto cranking this. So, any questions?
Would it make sense, the question just popped up in my mind, would it make sense to combine the project structure of a Shiny app with the project structure of an R package? Because a lot of times you might end up with a lot of functions in your Shiny app, and in your R package they would go into certain files and certain folders, and combining those two would make it more shareable in a way. I guess that to share in Shiny app, you would put the zip file, or you would send a zip file to someone else and zip it and unpack it. And
yeah, so there's a couple ways to answer that question. To share a Shiny app, there are a couple things you can do. We have a whole webpage about this actually. Oh, I forgot, sorry, one of the most important things. Shiny.rstudio.com. We launched this, this is a new site several months ago that we launched that has a very extensive tutorial on getting started with Shiny. We've got many articles on specific topics, and then many examples. So many examples. This was weeks of my life. And one of the articles is about how to share your apps. One way is, maybe the easiest way is if you have, if you use GitHub gists, you can go to this gist.github.com, paste in your UI.R, server.R, functions.R, your CSV data set, and Shiny has a built-in function for running these directly from GitHub. So you can say, Shiny run gist, give an ID or a full URL, and it'll download it, unpack it, run it, and then when you close it, it deletes it all. You can also do the same thing with a full GitHub repository. You can do a zip file, as you mentioned, and you can also package it up, as you were suggesting. So there's some details here, but basically, you would put your server.r and UI.R file into the inst directory of your package. That will just make sure that it's on disk when it's installed. And then you would provide a function in your package that runs Shiny pointing to that directory and take a dependence on Shiny.
Okay.
So it's all pretty straightforward.
How does the server component work? Is there a web server implemented in R? Or?
Sorry, what's the question?
How does the server's component work?
Oh, how does the server component work? Yes, so when you run a Shiny application right on your own machine, the HTTP UV package that Dirk mentioned has a built-in web server. And it's the same web server code that is in Node.js, if you're familiar with that. When I hit you can see here, it's pointing to port 3629. This is talking directly to HTTP UV, and Shiny uses that all under the covers. So I didn't really get into this, but if you want to deploy it, on your company network or to the cloud, we use a separate piece of software called Shiny Server that we have both open source and paid versions of that will do some proxying in front of your R instance. So instead of putting your R instance directly on the internet, you can run it behind Shiny Server, and that has all sorts of advantages. If your R application exits for whatever reason, if it has a seg fault or an error, then Shiny Server knows how to start it back up. Shiny also, if you're running it straight off of your machine, it's not compatible with IE8 or IE9. Maybe not IE10 either. It communicates back with R using a technology called WebSockets, which doesn't exist in those versions of IE. So if you run Shiny Server, it knows how to translate between things that IE does support and WebSockets, so you get that capability back. But yeah, those are the two primary ways you can run it, either locally, automatically using HTTP, or through the web using Shiny Server. Does that answer your question?
No. Is there any additional overhead on top of the overhead or the slowness of an R function itself that is generated by Shiny? Because sometimes it seems to me that it takes a little longer, but it might just be that you're not expecting a graphical user interface to take longer, but you're expecting your R code to take longer.
Right.
That's really weird though, and that bugs us a lot. So I mean, I work for financial companies, so a lot of the computing is done on Linux machines, and they're all for better or worse. So the Windows computers, I will put a change to that for my workstation soon, but it's in the Windows machine. And if I'm just sitting there and say plot something, and X11 when it comes over plot, that's not actually fast. Just from the look and feel and the guts of it, this is faster because it prints to file and then the file gets rendered, and it's seamless. I mean, we do this for series where we flip often around, and it's good. I mean, I did some additional playing just to get some data quicker into R, but the actual updating and rendering there's none. I mean, in a way, it's almost better just because the display technologies are so weird, and R's default graphics widget is weird. They're not fast.
For the particular examples I was showing tonight, the ones that weren't running locally were particularly big. That's probably a combination of number one, those are running on servers in the United States, and number two, they're running on quite small instances right now. So those are examples that are public. They're on our Shiny site, so there's always simultaneously several users using them at once. And that's the other thing that might lead to slowness for this versus just working on the console, is that if you have a Shiny app that's running on one R process and it's serving 10 users simultaneously, well, R is single-threaded. So at any given time, you can only be doing calculations on behalf of one user. Okay. And when that calculation is done, then it can serve someone else. But if you're doing simulations or something like that, you're going to be waiting in line. So that's one other reason to use Shiny Server is the Pro edition of that. In response to load, it can spin up multiple R instances and assign one to each user if that's what you prefer and you have the community resources for that. Any other questions?
Just maybe an additional question to this. The processor, so if I start switching between, different attributes, are queued, or are they just respawning different cores? Because
you're saying if you're switching very quickly?
I just experienced if you show it to other people and the performance is not that good and it takes a while when they keep pushing the button, and if you don't have anything which shows, okay, stop, I'm calculating, it just does something for a very long time, but I haven't really figured out what's happening.
Yeah, so I think there's really two things that we could be doing better there. Number one is showing clear progress when something is thinking, when it's recalculating. Right now, what we do is we wait 2 seconds and then we kind of fade out the controls that are pending recalculation. They kind of go to half opacity. But in some severe load cases, even that may not happen for a while. So that's one, is being clear about when we're thinking about it so you don't have to pound on the key. And second is, if you do hit that button a bunch of times and it queues up a bunch of inputs, does that cause a storm of recalculations one after another when all you care about is the last one? And because of Shiny's reactive programming framework, in a lot of cases we do sense that we can skip a bunch of work and we don't do it, but in other cases, especially when you explicitly put in an action button, we do currently just keep stacking up things to do when the best thing to do would be to just wait. And that's something that we need to address in a future version. So.
What is the recommendation in the meantime?
Yeah. Yeah, I mean, it really is very dependent on the particular application. So feel free to email me at joe@rstudio.com and we can talk more about it. It depends on, if you're doing inherently likely calculations that are just going to, be slow, there are ways that you can kind of proactively, put up alerts or disable buttons. Like you can literally have it so when it clicks, it turns gray until the system is at equilibrium again. So there's things like that. So, yeah, let me know. Yeah.
For these Shiny documents, are the reactive parts, are those limited to chunks, or can you have inline reactive expressions as well?
You can, let me read this. You can do inline reactives. I think the version of Shiny that made it to CRAN last week stopped short of that. But if you install from GitHub, then it should work.
Then you can do it, but they're block elements, so they don't really render in line.
Yeah, you may as well not.
May as well not
It's
have
not
them do it,
good.
yeah.
But it's fine.